So polynomial functions. It is a combination of monomials. A monomial just means it's one term, right? Separated by a term, right? Is separated by a plus or a minus with positive integer exponents greater than or equal to 0 with no variable in the denominator of a fraction. So part of our notes are going to be, is this a polynomial function or not, based on that definition, okay? So monomials are these guys, 1, 2, 3, 4, 5 monomials with positive integer exponents. So you'll see these exponents, we have a 4, a 3, a 2, a 1, and actually that's a 0, right? Because anything raised to a 0 power is 1. So we could call that 8x to the 0 power, right? Because x to the 0 power is going to be 1. 1 times 8 is 8. So I know I marked the letter, but I meant to mark the number with my highlighter. So you have exponents. They are all positive. That's a positive 4, positive 3, positive 2, positive 1, and a 0. They are greater than or equal to 0, and there are no variables in the denominator of a fraction. Let me show you some of the examples they ask us about. For example, here we have a variable in the denominator of a fraction. Good. That would be not a polynomial. There are no variables in the denominator of a fraction, and all of your exponents are greater than 0. Here's an exponent of 2, of 3, of 3, of 2, of 4. Okay, that's what they mean when they say that. That's what you should understand when they say that. Remember that denominator is just the bottom of the fraction. Okay. Standard form means you've arranged your exponents in descending order. For example, x to the 4th minus x to the 3rd plus x squared minus 3, right? Because then there's x, and then that would be your lowest in descending order because it's x to the 0 power. The terms are the number of monomials separated by plus or minus symbols. The leading term is the first term after you've written it in standard form, so it's going to be the term with the greatest degree, right? So in this case, our leading term is 5x to the 4th. The coefficients are the numbers multiplied with the variables. For example, -7 is the coefficient of -7x squared. I apologize. Good. So the coefficient is the number in front of the variable. 5 is the coefficient here. -3 is the coefficient here. -7 is the coefficient here. 2 is the coefficient here. We don't call 8 the coefficient. We call 8 the constant because it has no variable. Your constant is also your y-intercept. So here, -8 is the constant of this polynomial function. The degree is the largest exponent. So our leading term was 5x to the 4th. The degree of 5x to the 4 is 4. So we're saying this is a degree 4 polynomial. Because when we put it in descending order, the largest degree was 5x to the 4th. The leading term was 5x to the 4th. So it's a degree 4 polynomial because we're talking about that number. Good. The graph, when you graph it, is smooth and continuous. This is a polynomial because you can run your finger along it or a pencil along it. It's smooth. It doesn't stop, right? It continues. Here, you have a corner, you have a cusp, you have a gap, you have a hole. Not smooth, not continuous. Neither smooth nor continuous. Good. We want smooth. We want continuous. Any questions about polynomial? What a polynomial function is? Okay. Let's give you some examples of what are not polynomial functions, okay? Or sorry, ways that variables would not be expressed in polynomial functions. X to the power of 1/2 would not be in a polynomial function because 1/2 is not a whole number, right? X to the -5th would not be in a polynomial function because that is not greater than or equal to 0. And then, let's see, X over X squared would not be in a polynomial function because that is a variable in the denominator, okay? So these are not a part of polynomial function. Because the rule is your exponent is a whole number, your exponent is positive, and your variable is not in the bottom of your fraction. So we're just going to decide. Here we have P, F, G, H, and H. We'll just call them 1, 2, 3, 4, and 5. Are each of these polynomial functions, okay? If they are, put them in standard form and tell them the degree. If they're not, say why they are not polynomial functions, okay? Again, whole numbers, positive numbers, no variable in the denominator. All right, number 1 is P of X is equal to 4x cubed minus 1/2 x squared minus 7. This is okay. The x squared is not in the bottom of this fraction. The x squared is just being multiplied by a fraction. That's okay. So this is, excuse me, a polynomial function. It is of degree 3, and then they say put it in standard form. Standard form means descending order of exponents, x to the 3rd, x squared, x to the 0 power. So it's already in standard form. Good. Number 2, f of x is equal to x plus 3 minus 5x to the 4th. My exponents are positive, they're not negative, and my exponents are whole numbers. So this is a polynomial. What is its degree? Of degree, you just look for the biggest exponent, it's 4. Okay, and then they said put it in standard form. So in standard form means I'm going to take that negative 5x to the 4th and put it in front, followed by x, followed by 3. So I just put the variable, the exponent of the variable in descending order. Good. All right. Number 3, we have g of x is equal to the cubed root of x. So what's happening here is, if you remember, I know it was a long time ago, but if you remember, the root of a radical translates to a fraction of an exponent if you put it as an exponent. So the cubed root of x is the equivalent to x raised to the power of 1 over that root, and that root is 3. So this is actually x to the power of 1/3. That is not an integer, right? 1/3 is not an integer, it's a fraction. So because it's the cubed root of x, it is not a polynomial function. I can't just write x. I'll just write it's not a polynomial function because my exponent is not an integer. It's not raised to an integer. An integer is a whole number raised to a fraction. Number 4. Oh, we already marked it, right? This is in the denominator. So a variable is in the denominator. So it's not because the variable is in the denominator. It's not because it's raised to a non-integer. Sorry, I wrote those backwards. It's not because it's raised to a non-integer. It's not because there's a variable in the denominator. Letter number 5 is h of x is negative x to the third times the quantity x minus 3 squared. Okay. I don't see any fractions, right? I don't see any non-whole numbers, and I don't see any negatives as my exponents. So this is an example of a polynomial function. It's not in standard form yet, right? To be in standard form, we need to factor all of this out and then put them, all of our terms, in descending order of the variable. So what I'm going to do is I'm going to rewrite this negative x to the third times x minus 3 squared. Also, it's asking me what the degree is. Here it was very obvious. It's of degree 3. Here it's of degree 4. But we need to factor this out, not only to put it into standard form, but to determine what the degree is. Okay, so x minus 3 squared means x minus 3 times x minus 3, right? So we have negative x to the third times the quantity x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is a positive 9. Good. Now I'm going to take that negative 3 and distribute it. Negative 3 times a positive x squared is a negative x. We're going to keep the base the same and add the exponents. So that's x to the 5th. Negative x to the third times a negative 3. Those become a positive. 3x to the 3 plus 1 is 4. Negative x cubed minus 3x. Again, negative times a negative becomes a positive. 3x to the 4th. You could have also added those before distributing. And then negative x cubed times a positive 9 just gives me a negative 9x cubed. Good. So what that finally becomes is negative x to the 5th plus 6x to the 4th minus 9x cubed. That's in descending order, so that's in standard form. And of degree 5. Okay, one trick, if you don't want to do all of this, you don't need it in standard form, you just want to know what degree it is, you can take the exponent of this variable and the exponent of this variable and combine them. Negative x to the third times x squared is going to be x to the 5th, right? So it's a degree 5. It's a shortcut. But we will practice that, don't worry. So here's when you're looking at it, is it a polynomial function? Okay, you can look at it and say, are those whole numbers, are they greater than or equal to 0? And are they all in the numerator? If not, it's not a function. Now, if you're just looking at the graph, you're also welcome, right, to put all of these into a graphing function or sorry, like a graphing website or a graphing calculator and look at the graph. Is the graph smooth and continuous? Then it is a polynomial. Good. All right. Which ones could be the graph of a polynomial function? Remember, the rule for that is smooth and continuous. This one, this is not continuous, right? This one, nice, smooth, and continuous. This one, not smooth. These two could be the graph of a polynomial function. These two could not be the graph of a polynomial function because they are not smooth or they're not continuous. They have a gap in them. Good. All right. This is what they mean. Okay, the power function is another name for the leading term of your polynomial function, okay? The power function of degree n is the leading term of the function when written in standard form, right? So when you're looking at that leading term, 5x to the fourth, the power function is 4, for example, x to the fourth. Good. The graph of a polynomial function will resemble the graph of the power function. So if that number is an even number, the two, each end of the two ends or the two arrows will go in the same direction, both up or both down. If that number is odd, they will separate. One side will go up, one side will go down. Good. All right. So it's okay if that doesn't make perfect sense. What we are going to do is we are going to determine the power function of each of these. So remember, the power function is the degree, okay? The degree of the leading term. Here, 3x to the fifth minus x squared plus 2. What is the power function? The power function is just 3x to the fifth. Okay, so the power function is 3x to the fifth. Okay, the graph of the whole polynomial function, 3x to the fifth minus x squared plus 2, will resemble 3x to the fifth. Okay, now f of x equals 2 times x minus 2 cubed times x plus 7. It's not in standard form. You're welcome to take it and work it all out to put it into standard form. 2 times x minus 2 cubed times x plus 7. And writing that to 2 times x minus 2 times x minus 2 times x minus 2 times x plus 7 and solving that, right? Or you could just look at your leading terms, okay? Your leading terms are the 2, the x cubed, and the x. So that becomes 2 times x cubed times x. Okay, because we're only interested in what the first term is going to be, right? I'm going to take that x, it's going to be multiplied by that x, but that x is also already to the third power. So that x to the third is going to get multiplied by that x and by that 2. And what I will end up with is 2x to the fourth. Okay, so we're shortcutting all of this because we want the leading term, which if I do all of this, I will get 2x to the fourth as my leading term, but I don't need to know anything else about it. So I'm going to skip all of that extra work and just look at my leading term. Leading just means first, right? 2 times x to the third times x. This one's just raised to the first power. 2 times x to the third times x is 2x to the fourth. Here, our leading terms are x, x squared to the second power, and x. Okay, so when I write that out, it's x times x squared raised to the second power times x. That's all we're doing. Okay, so that becomes x times x to the fourth, right? Because 2 raised to the second power is 2 times 2, which is 4, times x. And if I add those together, that's just going to be x to the 6th, right? So the power function here is 3x to the 5th. The power function here is 2x to the 4th. The power function here is just x to the 6th. Good. All right. Let me see. I'm going to pause. So that is what they mean when they ask for your power function, okay? real zero. A real zero, if you imagine a graph, right? The graph of a function. A zero is where that graph is going to cross the x-intercept, right? So we call the real zeros of these polynomial functions R, and R is the x-intercept when you graph it, okay? Remember, to find the x-intercept, we set y equal to 0, so that means that when y is 0, x is R, okay? So, and x minus R is a factor of the function, right? It's a solution to the equation f of x equals 0. So it's x when y is 0. It is the x-intercept, and it's a factor when you put it, when you combine it opposite with x, right? So just like if we had 0 equals x plus 5 times x minus 3, we could solve that and say 0 equals x plus 5. So x is -5, right? 0 equals x minus 3. So x is a +3, right? So those factors are how you find x. So that's what this is saying. If I know that x is -5, then I can say x plus 5 is a multiple of the function f. Good? So that's what a real zero is. You are familiar with this. It's just a new context for it, right? If x minus 3 is equal to 0, then x is 3. So a real zero, you can change the sign and combine it with x and get a factor of the function itself. On top of real zeros, we have their multiplicity, or the number of times the factor occurs. So think of your real zero in this form as a factor of f, right? Now their multiplicity is that number of times the factor occurs. Okay? So we said x minus r is a factor of the whole polynomial, right? That m, when m is odd, the graph will pass through the x-axis at that 0, right? We know it's an x-intercept. So if this number is odd, it passes through the x-axis. If that number is even, it will only touch the x-axis and then turn, touch and turn. Good? So, for example, an odd exponent, here's my x-axis. Good? An odd exponent will do this. It will cross it. Right? Such as x cubed. X cubed looks like this, right? X cubed passes the x-axis. However, even touches the x-axis and comes straight back up or down. Oh, I didn't even get it to touch. I was too shy. Good. For example, x squared, when you pack, or this will be negative x squared, right? When you imagine x squared, you're imagining a parabola. When you imagine x cubed, you're imagining more of a shape like that, right? So any even exponent is going to touch and turn, either come up and go back down or go down and come back up. If it's odd, it's going to cross the x-axis and keep going, okay? So it sounds more complicated than it is, but what we're going to do with that information is take something like this, identify the real zeros, state their multiplicity, and describe what that means on the x-axis. Then we'll just look at it as a graph, all right? So identify the real zeros. Remember, a real zero looks like x minus r as a factor, okay? A real zero is r of the factor x minus r. State their multiplicity. That's this guy up here. And then describe whether that means that they pass through or touch. Okay, so the real zero, x minus that real zero is a factor of the polynomial function. Okay, so let's look at each one. We have x plus 5. We have x minus 2 squared. We have x minus 4, and we have x plus 1. Okay, so I just picked out all of my factors of f of x. Okay, then we're just going to go through. We're going to pick out what r is for each one. Okay, identify the real zeros. For x minus 3, the real zero is 3 because x minus r is a factor. Okay, x minus r is a factor. X plus 5, you can just set that equal to 0. X plus 5 is 0. X is negative 5, so r is negative 5. Right? X minus 2, r is going to be a positive 2. X minus 4, r is going to be a positive 4. X plus 1, r is going to be a negative 1, right? Because if I put x minus negative 1 in, I get back to x plus 1. X minus 4, I get back to x minus 4. X minus 2, I'm back to x minus 2. Good? So you're just changing the sign of that factor to find r. Here the r is negative 5, here the r is positive 2, here the r is 4, here the r is negative 1. Those are our real zeros. State their multiplicity. Good. So what is the multiplicity of negative 5? What is the multiplicity of positive 2? What is the multiplicity of 4? And what is the multiplicity of negative 1? Good. And you just look. If there's nothing here, it's an understood 1. So this has a multiplicity of 1. This has a multiplicity of 2. This has a multiplicity of 1. This has a multiplicity of 1. Sound okay? If your multiplicity is odd, it passes through. And you can call it cross, you can call it whatever you want. Just trying to, I'm not very consistent, so I'm trying to be consistent. If it's even, it will touch. 1 is an odd number, so it passes. 2 is an even number, so it touches. 1 is an odd number, so it passes. 1 is an odd number, so it passes. Or crosses the x-axis. Good, and you can even draw a little picture, right? This passes through the x-axis. This touches the x-axis. This passes the x-axis. This passes the x-axis. Good. So my real zero is negative 5 with a multiplicity of 1. Real zero is 2 with a multiplicity of 2. R is 2 with a multiplicity of 2. R is negative 5 with a multiplicity of 1. R is positive 4 with a multiplicity of 1. R is -1 with a multiplicity of what? Now, describe the interaction with the x-axis and verify using a graphing utility. I should actually. Let's imagine now, okay? R is a real zero, it's an x-intercept. So that means there is an x-intercept at -5. And it's going to pass through at -5. There's going to be an x-intercept at 2. And it's going to touch. There's going to be an x-intercept at 4. And it's going to pass. And there's going to be an x-intercept at -1. And it's going to pass through. Let's put those in order. So we have -5, it's going to pass. -1, it's going to pass. +2, it's going to touch. And 4, it's going to, what did we say? Pass. Pass through. Good. So let's just imagine what this might look like. It might be at -5, it's going to pass through. At -1, it's going to pass through. At 2, it's going to touch. And at 4, it's going to pass through, right? Example 5 asks us to find a polynomial function of degree 3 with the real zeros -1, 2, and 3. Remember, a real zero, the factor of a real zero is x minus that real zero, right? So the real zeros are -1, 2, and 3. That means I have R is -1, R is 2, R is 3. So according to this formula, I just put in -1, 2, and 3 for my R's. X minus -1 times x minus 2 times x minus 3 can be simplified to x plus 1 times x minus 2 times x minus 3, right? And it says it's a polynomial of degree 3. That's important. Of degree 3 means that we need to check if this is just raised to the first power, this is raised to the first power, and this is raised to the first power. Do we get a polynomial function of degree 3? We do, because x times x becomes x to the third. So our polynomial of degree 3 is x plus 1 times x minus 2 times x minus 3. They might ask you to put it in standard form. So you could also call it you just FOIL it. X times x is x squared. -2x plus x minus 2. So that's x squared minus x minus 2 times x minus 3. Becomes x to the third minus x squared minus 2x minus 3x squared minus 3x plus 6. So that would be it in standard form. And if you put that into Desmos, or you put this into Desmos, what you would get is a graph that crosses the x-axis at -1, 2, and 3, right? Okay. Example 6 asks us to find the real zeros and state the multiplicity of f of x equals 6x cubed times x minus 5 times the quantity x plus 1/4 to the 4th power. Good. So find the real zeros, state their multiplicity, and decide if the graph will touch or cross the x-axis at each of those points. F of x equals 6x cubed x minus 5 times x plus 1/4 to the 4th power. Okay, so we have the factors 6x to the 3rd, x minus 5, and x plus 1/4 to the 4th. Okay, so when we're thinking about this as a real zero, 6x to the 3rd, its multiplicity is 3, right? This multiplicity is 1, this multiplicity is 3, this multiplicity is 4. But 6x to the 3rd, what is the real zero of 6x to the 3rd? What are we subtracting from x? We're not subtracting anything, right? So 6x to the 3rd, set it equal to 0, divided by 6, right? The real zero I'm going to get is 0. If I set this equal to 0, I'm going to get my real zero is a positive 5, right? If I set this equal to 0, my real zero is going to be a negative 1/4, right? We're not adding or subtracting any number. We're adding or subtracting 0, right? So our real zero is 0. What is the degree or the multiplicity of 0? The multiplicity is 3. Here my multiplicity is 1. Here my multiplicity is 4. So those are the zeros. The zeros are 0 with a multiplicity 3, right? 5 with a multiplicity of 1, and negative 1/4 with a multiplicity of 4. 3 is, and so now they just want to know, is it crossing or is it touching? Or is it going through or is it touching? 3 is odd, right? 1 is odd. 4 is even. And what is the rule? It's on the back of this. The rule was, if it is odd, it passes. Oops, sorry. If it's odd, it passes. If it's even, it touches. Sorry, I'm losing my voice, but we only have a few more minutes, right? Okay, if we had to imagine this, it's going to pass through 0. It's going to pass through a positive 5. And it's going to touch at negative 1/4. So we don't know how far up and down it's going, right? We don't even necessarily know if it's opening up or opening down, but we can put this into a graphing calculator and verify that it does pass through 0, pass through +5, and touch at -1/4. Yep. Okay, example 7. Consider the polynomial function f of x equals x minus 3 squared times x plus 4. Find the real zeros. State their multiplicity. A real zero in factored form is going to be x minus that r, right? So that means my real zeros are 3 and -4. State their multiplicity. The multiplicity of the +3 is going to be multiplicity of 2. The multiplicity of the -4 is just going to be an understood 1, right? Because there's no number there. Find the y-intercept. We haven't done this yet. What you want to do, just the same way that we were able to find the power function. Remember, we found the power function by multiplying the first terms, 2 times x cubed times x. You can find the y-intercept because you know that the y-intercept is the constant. The number without a variable is your y-intercept. Here it's a -8. Here we still have it in factored form, but that's okay. To find the y-intercept, you want to multiply your constants. So we're going to multiply -3 squared and 4. Don't forget to include the power sign and whether it's positive or negative. We're not multiplying the real zeros, we're multiplying the constants, the -3 squared and the 4. -3 squared becomes 9. 9 times 4 is 36. So the y-intercept is at 0.36.